Hello Form 5 students, today I'm going to teach you how to draw a line of best fit for linear law. Let's have a look at this question. This question is from the module T2V. So table 10, let's see the question. Shows the values of two variables x and y obtained from an experiment. Two variables x and y are related by the equation xy minus yb equal to a, such that a and b are constant. So we have x value and y value. All these are experiment data. And then you're asking to construct a table for the values x, y. And then after that, you will have to plot y against xy and using the scale 2 cm to 20 unit on the xy axis and 2 cm to 2 unit on the y axis. Hence, draw the line of best fit. Today, my main concern is this one. I'm going to teach you what it means by line of best fit. After we have lines of best fit, we can use the graph to find the value of constant A and constant B. Right, then after that we are going to use another method, getting the straight line for the above nonlinear equation by plotting 1 over y against x. Without drawing the second graph, calculating the y-intercept of the graph. So let me show you how I will plot the graph using the Geogebra and make you understand the concept. This is the point A. Let's say we have the point A, point B. Okay, let's see where is our point A. This is a point A. Okay, we have to plot the point one by one. Then we have point B, which is here, 26.6 and 18.2. And point C is, I'm going to plot the point C right now, 58.9 and 13.3, right? And then for point D is 90.2 and 8.9. And for point E is 114.9, 6.3. And finally we have 150 and 150.2 and 1.5. So we have all the 6 points already, right? Now the problem is how to draw the line of best fit. Okay, I'm going to explain to you what it means by line of best fit. So let's have a look of the point. Let's say I'm going to show you, we try to figure out which line is the line of best fit. So let me use the line of best fit line here. Okay, I'm going to explain to you, for a straight line we need 2 points, isn't it? Let's say you choose AB, you want to draw the line of best fit. Let's say just by using 2 points we can draw the line of best fit. Okay, now if you choose A and B, you choose A and B here. So let's study, is this line a line of best fit? I'm going to use a color to explain to you. The point which is exactly on the line, I use green color. Okay, so this one is exactly on the line, so I'm going to use green color. We have 2 points on the line, but we have 1 point which is out of the line. I use a red color. This is another point that is out of the line. Alright, and then I have 1 more point which is out of the line. So 3 points out of line, and this one is worse, is also not on the line. So out of 6 points, as you can see, only 2 points on the line and 4 points are out of the line. So this line is actually not line of best fit. The purple line, not line of best fit. Okay, let's say you choose we change another point. A and B cannot form the line of best fit. So we are going to, okay, delete the line. Let's change maybe A to C. Okay, I'm going to change A to C. Let's delete the line first. Okay, let's try another one. We are going to try another point, see whether we can get the line of best fit using other option. Let's say I'm using B and C. I'm going to use B and C to just now the line that we form is A and B. We cannot get the line of best fit. Now I'm going to try B and C. So I'm going to try whether B and C can give me line of best fit or not. So B, C. Okay, let's see. Let's study the point on the line. Okay, if this line is out, I will use a red color. So this point is out. We have one on the line. We have this one is on the line, so use green color. This one still on the line. This point was out. It looks like okay at this point, but you see F is above the line. We have 2 points above the line and 1 point below the line. So this line is not line of best fit, because for a line of best fit, number of points below the line and above the line must be balanced. Okay, must be balanced. So even though it passes through 3 points, but number of points below and above the line are not equal. So this is not line of best fit. Alright, let's try another possibility. So this line we consider not fit. Okay, we will try another possibility. So you have to adjust your ruler until you can see the line of best fit form. Okay, I'm going to use a C and D. Okay, let's see if C and D, let's have a look. It looks like A is out, B on the line, C on the line, D 3 point on the line, and E out, F out, right? This one is not fit, right? Now C and D is also not the line best fit. It's actually the same like just now B and C, right? Because this line is passes through B, C, D. So B, C, and C, D are having the case, same case, same scenario. So they are not line best fit. Now I would like to try maybe combination between D and E. Okay, this line we delete. We try to form a line of best fit, see whether can get if we try D and E. So I'm going to form the line of best fit, see whether I can get the line of best fit using this line, the blue line. Now let's study. As I say, the line which is out, I will use the red color. This one is out of the line. This is good, it's exactly on the line. This is exactly on the line. Yeah, we have 2 points on the line. And we have 1 point which is out, this point out. So it looks like we have 2 point. Okay, if the point is above the line, this one is out, right? Let's highlight. Okay, if it is out, we count the point above the line, we got 3 points, right? Below the line we got 1 point, not balanced. So we can say that this line is not the line of best fit. So the line DE is not line of best fit, because number of point above the line and number of point below the line are not equal. Alright, now let's choose maybe another possibility. We can form the equation, either we use EF. Okay, let's try EF. So I delete the line. We still can't get the line of best fit, so I'm going to try another possibility so that you can see why that line is not line of best fit. Okay, I'm going to plot the E and F. E and F. Right, let's study the point on the line. As you can see, for this line, let's use a okay, this color. Now we can see that this point, it was out, right? It was out of the line, so we use red color. And then this point also out. Okay, if we use a red color. And then this point E is exactly on the line. Yeah, it's on the line. F is exactly on the line. So we have 2 points on the line. We have this point is on the line also. Let's see. We have 1 point A out. C is out. If you zoom closer, it looks like it's out. And then for this point, D also out. So for F, yes, we have 2 points E and F on the line. But then, as you can see, we have 3 points B, E, F on the line. But it seems like the number of points below the line are not equal. We have A and C below the line. And also 3 of the points are below the line. This is totally unacceptable. It's not fit enough, right? It's below the line. Okay, so this one also not the line of best fit. So the best line that we will stick to, if you really adjust the line, you will notice that the best line is, let's try another possibility. Okay, let's draw another combination of the line. We just need 2 points, right? Okay, I'm going to use C and the last point, CF. Alright, again, CF. Alright, let's study here. Let's study the line CF. Is it line of best fit? Now, as you can see, this point was below the line. The point A below the line. Point B above the line. These two are out, but they are one above, one below. They are balanced. This point is on the line, exactly on the line. And this point out below the line. And this point also out. Right? It's above the line, isn't it? And the last point is exactly on the line. As you can see, let me highlight to you. See, again, this is very beautiful. You see, the last point is exactly on the line. C and F are the 2 points exactly lies on the line. Exactly. And we have, in fact, we have 4 points which are not on the line, but they are in order. One above, one below, one below, one above, one below, one above. They are symmetrical. They are balanced. Okay. So as you see, this line is considered the best out of the best, the line of best fit, because it actually forming the line whereby point A and point B, one below, one above, and point D and point E, one below, one above. And there are only 2 point lines on the line. It's okay, but because the number of points below the line and above the line are equal, so this is so-called the best line. We call line of best fit, right? We call line of best fit. With that, we can read the y-intercept, which is 20.9. It's the best y-intercept for you to solve the constant 20.9. Right? You can study again. The point is arranged in such a way we call line of best fit. Again, I show you point A below the line, point B above the line, point C on the line, point D below, point E above, and then point F is exactly on the line. So the most beautiful line, or we call as line of best fit, is this one. Is represented by this, right? So we will consider all the points, arrangement of all the points. The number of points below and above the line must be balanced. Okay, so we have understand the best line of best fit. We can use it to find the gradient, and then after that we can solve the constant. In fact, we can write down the equation, and the equation is this one: y equal to negative 0.1 x plus 20.9. Okay, negative 0.1 x plus 20.9 is the line of best fit. So we can use this graph to solve the constant by using the y-intercept and the gradient, right? So that's all my sharing. Till then, bye bye and have a nice day. So for B1, as you can see that big Y is small y, 1 over B is a gradient, and then this is a big X, and then this is a C, right? So we always draw the arrow pointing to the big Y. This is a big Y. This whole thing is a gradient. This is a big X, and this is C. C is inclusive of the negative B over A. It's inclusive of negative, and gradient is 1 over B. So 1 over B is negative 21 over 162. So we will compare and we read the B. And for the question 2, in order to find the A, we have to use the y-intercept, right? Okay, the y-intercept, negative A over B equal to 21, and the A is 162.12. For the last part of it, I'm going to take out the y, factorize, I will get A, and then I will divide by y, divide by y, divide by A, divide by A. So I will get 1 over y is equal to x over A minus B over A, right? So hence I can say 1 over y is 1 over A x minus B over A. So my y-intercept is this one, so C is negative B over A. So I can substitute the value just now. The constant that we got is here, negative 7.72, negative 7.72 over 162.12. So we will get the y-intercept for this C, which is a bit different from just now, 7.72 over 162.12. So let's divide 7.72 divided by 162.12. Our answer is 0.04762. This is a constant C.